Hello students, welcome to physics online classes. So in last lecture we have discussed the basic concepts, the introduction part as well as different types of stress and strain, right? So in this lecture we are going to discuss few problems based on stress and strain calculations, out of which here is the first problem. Pause the video, first try this question from your end. Right, let's move on to the solution part. See here in the question, they are giving the radius ratio of same material, that is 2 is to 1, and asking to calculate the ratio of stress when the same force acts on it. So what is the general formula of stress? Stress is force by area, right? So they are saying force is constant, so that what we can say, stress is inversely proportional to area. So as the wires are cylindrical in shape, so circular cross sectional area is pi r square, so S is inversely proportional to r square. So the required ratio of stress S1 by S2 is equals to R2 by R1 whole square, where R1 by R2 given is 2 by 1, so R2 by R1 is 1 by 2 whole square, which is 1 by 4. So the ratio of stress S1 is to S2 is 1 is to 4. So the suitable option is option 3. Next, let's move on to the other question. So pause the video, try from your end first. So in this question, they are asking to find the longitudinal stress as well as tangential stress. So the given diagram is, a block is placed on the floor in such a way that 5 meter 2 meter area is 5 into 2 meter square area is on the floor, and the height of the block is 1 meter, and 100 Newton force is acting on the top surface by making 30 degree with the horizontal. Suppose if this is the surface, this is the horizontal, and force is acting in this manner, so this way. So here it is 30 degree, and you already know that if the force is acting perpendicular to the surface, there is longitudinal stress. If force acts parallel to the surface, there is tangential stress, or you can say shearing stress. And in case if the force acts by making some angle with the horizontal, in that case there exists both tangential stress and longitudinal stress. So first of all, according to the given data, so let us find the parallel and perpendicular component of force. So here the given force 100 Newton is acting by making 30 degree with horizontal. So say this is tangential component and this is a longitudinal component. So the tangential component is equals to f cos theta, that is 100 cos 30, which is equals to 100 into root 3 by 2, which is 50 root 3 Newton, tangential component. And the longitudinal component is f sin theta, which is 100 sin 30. Sin 30 is 1 by 2, 100 into 1 by 2. So the longitudinal component is 50 Newton. So here they are asking two questions, that is longitudinal stress as well as tangential stress. So longitudinal stress is equals to the longitudinal force per unit area, that is 50 by what is the area of cross section of this top surface, that is 5 into 2. So 5 into 2. So the required answer is 5 Newton per meter square. In the same way, tangential stress is equals to tangential force by area, that is 50 root 3 by same area of cross section, right, 5 into 2, which is equals to 5 root 3 Newton per meter square. So with this logic, longitudinal stress and tangential stress correspondingly 5 Newton and 5 root 3 Newton per meter square. So 5 Newton per meter square and 5 root 3 Newton per meter square respectively. option 1 is the suitable answer. So then let's move on to the next question. So first read the question, pause the video and try from your end. Right. So they are saying a rod of 2 meter length having radius 1 centimeter which is fixed at one end. So this is a fixed end. Given a twist of 0.8 radians. So at the other end. Now they are asking to find the shear angle. So they are asking to calculate shear strain or shear angle developed. So we have discussed in the concept that if one end is fixed and the other end is like a tangential force acts at the other end, we got the relation between angle of twist and angle of shear. See here, theta is the angle of shift, phi is the angle of shear, right? So here theta is arc length by angle, right? So theta is arc length is L by radius, arc length by radius. So as I'm using capital R, so let us use the capital R. So then arc length is equals to theta into R. In the same manner, phi is equals to arc length by radius, that is L by capital L. L is theta R. So the required angle of shear is equals to theta given is 0.8, radius given is 1 centimeter, that is 10 power minus 2, length given is 2. So that is 0.4 into 10 power minus 2, so that's 0.004 radians, right? So now the suitable answer is 0.004 radians. Next, let's move on to the next question. Students, all of you first go through the question and then pause the video, try from your end. Right. So here the breaking stress of steel given as 7.9 into 10 power 8 and the density of the steel is given as 7.9 into 10 power 3 kg by meter cube. So they are asking to calculate the maximum length of steel wire so that it may not break under its own weight. So first of all, the general formula of breaking stress is breaking force by area. You know that breaking force depends on nature, temperature, area of cross section. Nature, temperature, impurities added. So breaking stress is independent on the dimensions such as length, area of cross section. And breaking force is directly proportional to area. So we learned that breaking force as breaking stress into area of cross section. As breaking stress is fixed for a given material, breaking force is directly proportional to area. See here, breaking force is independent on the length. It depends on nature, temperature, impurities and area. So as they are giving difference in, here as they are asking to calculate the maximum length so that it cannot break. So that we are going to calculate. Breaking force is like a load, that is weight. Density is mass by volume. Mass is density into volume. Volume is again area into length is equals to breaking stress into area. Area term will cancel. The required maximum length is equals to into G is as usual. So breaking stress by D into G. So breaking stress given is 7.9 into 10 power 8 by density is given as 7.9 into 10 power 3 into acceleration due to gravity 9.8. 7.9 cancel. The maximum length is 10 power 8 by 10 power 3 is 10 power 5 by 9.8, which can also be written as 100 by 9.8 into 10 power 3 meter. So approximately, in case if it is 100 by 10, 10 kilometer. But here is 100 by 9.8. So the suitable value is 10.2 kilometer. Right, students? So then let's move on to the next question. First, pause the video, try question from your end. Okay? Right. So let's move on to the question. Here they are saying that a uniform rope of mass M, length L, on which a force F is applied at one end. So in this way, and they are asking to calculate the stress in the rope at a distance x from the end where force is applied. So they are asking to calculate the stress at a distance x from the end where the force is acting. See students, in case if they give one more force this side which is having equal magnitude, simply we can say this rope or rod is in equilibrium, so the stress at any point is F by A. But here force is acting only on one side, so F is equals to MA, acceleration A is equals to F by M. So to calculate stress at this particular point, so you have to calculate tension at this point. So that tension by area is itself the required stress. You can find this either by drawing free body diagram of the x part or free body diagram of L minus x. If the length of the rope is L and if you want the stress at a distance x from this end, the remaining part is L minus x. So here what I can suggest is, if you draw free body diagram of x part, so there are two forces. F is right side, tension will be left side if you draw free body diagram of x part. But if you draw free body diagram of L minus x, only force acts is tension. So easily we can calculate. So according to Newton's second law, F is equals to MA, as only one force acts, that single force is tension, mass of the L minus x part into acceleration. How to calculate mass of L minus x part? Say for example, if you have a wire of length 5 meters, say for example, and the total mass is 10 kg. If you want to calculate mass of 1 meter length, which is mass per unit length into length, so that is 2 kg. If you want to calculate mass of 2 meter length, that is mass of 2 meter length, previously mass of 1 meter length. So it is mass per unit length into required length. So that is 4 kg. If you want to calculate mass of 3 meter length, mass per unit length into 3 kg. If you want to calculate mass of x part, that is mass per unit length into x. If you want to calculate mass of L minus x part, that is m by L into L minus x. So here mass of L minus x part is mass per unit length into the length, that is L minus x, into area is, acceleration is force by mass. M cancel, T is equals to F by L into L minus x, send L inside, so that is L by L minus x by L, that is F into 1 minus x by L. The required stress at a distance x from the point where the force acts is equals to T by A, that is F by A into 1 minus x by L. So the suitable option is option 3, F by A into 1 minus x by L. So now let us move on to the next question. First, pause the video and try this question from your end. Sixth question. Right. So here they are asking to calculate breaking stress. They are saying when the diameter is 2 millimeter, breaking force. Breaking force is 4 into 10 power 5 Newton. And they are asking to calculate the breaking force when the diameter is 1.5 millimeter. So just now in one of the above question I said breaking force is independent on length but depends on area. If they say length changing in the question, if they are saying difference in the length, there won't be any change in the breaking force. But here they are saying change in the diameter, that is nothing but change in the area. So there is change in the breaking force. As breaking force is breaking stress into area, As breaking stress is constant for a given wire, breaking force is directly proportional to area. Area of cross section is pi r square. So breaking force is directly proportional to r square. Radius is d by 2. So breaking force is directly proportional to square of the diameter. So new breaking force by existing breaking force is equals to d2 by d1 whole square. New breaking force by existing breaking force is equals to, so d2 by d1, that is 1.5 by 2 whole square. So that d2 is equals to 1.5 is 3 by 2, 2 into 2 4, 3 by 4 whole square into original breaking force. So that is 9 by 16 into 4 into 10 power 5, which is 9 by 4 into 10 power 5 Newton. So the new breaking force is 2.25 into 10 power 5 Newton. So the suitable option is option 1. They are giving 2.3, they might have rounded it off. Next, so let's move on to the next question. Pause the video and try this question. Right. So this is like two axial forces are acting on the rope or wire. Now in this case, magnitude of forces given are same, and here I am asking to calculate the normal stress on the cross section YB. So normal stress on the cross section YB means we have to calculate the component of force perpendicular to the cross section YB and area of YB part. Here they are saying transverse cross section of the wire is A, that is nothing but area of cross section of this part is A, that is what they are giving. From this we have to calculate area of YB and perpendicular component of force to this particular YB section. See, let us redraw the diagram. Right. So here see, given data is transverse cross sectional area is A, and section YB is making an angle theta with transverse cross section. Forces acting are of equal magnitude on both the ends. If this angle is theta, this is also theta. So from the diagram, from right angle triangle XYB or YXB, cos theta is equals to adjacent side XY section by YB section area. So the required YB section area. So area of YB section is equals to area of XY section by cos theta. So that is equals to A by cos theta, as they are giving area of XY section, that is transverse cross section, is A. Now if this is F, so the rope is in equilibrium. Tension at each and every point will be equal to F. So at this point, this side tension is F. Now we have to calculate the perpendicular component of force, say F1. See, just for my convenience, here I am drawing a vertical line. If this is theta, this is theta. And then as the angle between this horizontal and vertical is 90 degree, this is theta, so it should be 90 minus theta. And as this is a perpendicular component to this YB section, so if this is 90 minus theta, this is theta. So then if this is F, what is F1? F1 will be equals to F cos theta. F cos theta or F1 is the force perpendicular to the section YB. So they are asking to force calculate normal stress on section YB, that is equals to normal force by area of that section YB, that is equals to F cos theta by area is A by cos theta, area of section YB. that is equals to f by a cos square theta. So the suitable answer is option 1. See students, in the same question, if they ask you to calculate the tangential stress or parallel stress, in such case you have to take the force acting along this component by area of this section. Right students? So these are the few questions which are the calculations of stress as well as strain. So in case if you have missed the video which is a conceptual video of stress and strain, so I will be giving the link of the concepts of stress and strain and different types of stress and strain under this video. Go through this video so that it will be very clear for you. So we'll continue Hooke's law and stress strain curve in the next lecture, that is in the next video. Until then, take care. Bye bye students.